Somewhere past Neptune, in the coldest dark of our own solar system, something enormous may be hiding. A world roughly 10 times the mass of Earth that no human eye, no satellite, and no telescope on this planet has ever actually seen. Every piece of modern technology we possess, from space observatories to supercomputers, has failed to catch even a glimpse of it. And yet, a century and a half ago, humanity found a planet this exact same way, using nothing but a pen, paper, and pure mathematics. So what is really out there, silently circling in the frozen edge of our own backyard? There is a strange kind of confidence that comes from doing math before you do observation. Long before anyone points a telescope at the right patch of sky, an equation can already whisper that something is there, waiting. This is exactly the position two scientists found themselves in the mid-2010s. Staring at numbers that simply refused to make sense unless something massive and unseen was quietly rearranging the outer solar system. It began as many great discoveries do, almost by accident, not in a lab, but in a shared office at the California Institute of Technology, where two researchers kept noticing something odd every time they pulled up the latest data on distant icy objects. Have you ever had a hunch nag at you so persistently that you couldn't let it go, even when everyone around you assumed it was nothing? That is roughly what happened to Konstantin Batygin and Michael E. Brown. Batygin, a young theorist with a gift for orbital mechanics, and Brown, a veteran planet hunter with a very particular reputation, began comparing notes on a peculiar pattern among a handful of far-flung icy bodies at the edge of the solar system. Individually, none of the anomalies seemed like much, but together, laid side by side, they formed a pattern too consistent to dismiss as coincidence. The two spent roughly 2 years quietly testing the idea, running simulations, trying to break their own hypothesis before anyone else could. According to accounts from Caltech, some of their key breakthroughs came not in a sterile lab, but during long informal conversations over coffee near the Pasadena campus, where the pieces of orbital data finally seemed to click into place. It is a reminder that modern science, for all its supercomputers and satellites, still sometimes runs on caffeine, intuition, and two people willing to stare at the same strange numbers until they made sense. Michael Brown, in particular, arrived at this project with a rather unusual claim to fame. Nearly a decade earlier, in 2005, Brown had led the team that identified a distant icy world named Eris, a discovery that turned out to be almost the same size as Pluto. That single discovery kicked off a chain reaction that no one fully anticipated. If Eris deserved to be called a planet, then so did a growing list of other icy bodies being found in the same region, or alternatively, maybe Pluto never deserved the title in the first place. Brown leaned into the controversy so completely that he began referring to himself, half-jokingly, as the man who killed Pluto. That joke became reality on August 24, 2006, when the International Astronomical Union met and formally redefined what a planet actually is. Under the new definition, Pluto no longer qualified. It was downgraded to a dwarf planet, a term that still stings for anyone who grew up memorizing 9 planets in school. But that redefinition did something else, something quieter and more important. It opened up conceptual space. If the solar system's rulebook could be rewritten once, based on new evidence, it could happen again. The idea of a genuine Planet 9, an actual undiscovered major planet, was no longer unthinkable. It was, in a strange way, made possible by the very event that had just erased one. For nearly a decade after that, Brown kept circling back to the outer solar system, unable to shake the feeling that something didn't add up. When Batygin joined him and began applying rigorous orbital modeling to the strangeness Brown had been tracking, the pieces finally started falling into place in a way that felt too clean to ignore. Every simulation the pair ran, every alternative explanation they tried to force the data into, kept pointing back to the same conclusion. Something massive, far beyond Neptune, was shepherding the orbits of a cluster of icy bodies in a way that could not plausibly happen by chance. On January 20, 2016, Batygin and Brown went public. In a paper released through Caltech, they announced mathematical evidence for a planet roughly 10 times the mass of Earth, orbiting the Sun at a staggering distance, far beyond anything previously charted with confidence. The announcement rippled through the scientific world almost instantly. Here were two credible researchers from one of the most respected institutions on the planet, not claiming to have photographed a new world, but claiming that the math left almost no other explanation. It was audacious. It was, in the eyes of some colleagues, almost unbelievable. And it set off one of the most compelling scientific hunts of the 21st century, one that years later is still not finished. So why were two scientists willing to stake their reputations on a planet nobody had ever seen? The answer lies in a set of numbers so specific, so oddly aligned, that they are almost impossible to write off as coincidence. Numbers that describe a world so strange, so distant, and so slow-moving, that it becomes easier to understand exactly why it has stayed hidden for so long. Try to picture for a moment a planet that takes longer to complete a single orbit than the entire span of recorded human civilization. That is the kind of scale we are dealing with when we talk about Planet 9. According to the calculations from Batygin and Brown's original research, this hypothetical world would carry a mass somewhere around 10 times that of Earth, with a diameter roughly 2 to 4 times larger than our own planet. That places it in a very specific category. Not a rocky world like Earth or Mars, but a gas-rich ice giant, much closer in character to Neptune than to anything with solid ground to stand on. Now consider the distance. Earth orbits the Sun at a distance scientists casually refer to as 1 astronomical unit, or 1, a convenient baseline for comparison. Planet 9, if it exists, would orbit somewhere between 400 and 800 ASJ from the Sun. That means it could be sitting 400 to 800 times farther from the Sun than we are. Does a number like that even mean anything on a human scale? Probably not, and that is precisely the point. At that kind of distance, the physical and observational rules that normally apply to planet hunting essentially stop working. Distance alone would be daunting enough, but there's a second factor working against every telescope pointed in its direction: time. A single orbit around the Sun at that distance would take somewhere between 10,000 and 20,000 years to complete. Human civilization itself is barely older than that. No person, no team of astronomers, no single human lifetime has ever had the chance to watch this object complete even a fraction of its journey around the Sun. It also means the planet is moving so slowly across the night sky, by some estimates as little as roughly 0.02 degrees per year, that distinguishing it from the vast motionless backdrop of stars becomes an almost impossible needle-in-a-haystack problem, one that could keep even patient astronomers searching for decades without success. Then there is the matter of temperature. Calculations place the surface temperature of Planet 9 at somewhere around -226 degrees Celsius. Colder even than Neptune, whose surface already sits at a brutal -214 degrees. At that kind of temperature, in that kind of isolation, an object emits almost no detectable heat and reflects only the faintest trace of sunlight that manages to travel that far and bounce back, which brings us to brightness, or rather the near total absence of it. In 2019, Brown and his research team estimated that Planet 9 would shine at roughly magnitude 22.5. To put that in perspective, that is roughly 600,000 times fainter than the dimmest star visible to the naked human eye. This single fact alone explains why no backyard telescope, no matter how expensive or well-aimed, is ever going to stumble across this planet by accident. Finding it requires some of the most powerful, most specialized instruments ever built by humanity, pointed at exactly the right patch of sky for an enormous amount of time. Put all of these numbers side by side, the mass, the staggering distance, the multi-millennia orbit, the extreme cold and the near-invisible brightness, and a rather uncomfortable picture starts to form. This is not a planet hiding by bad luck. This is a planet that appears almost mathematically engineered by nature itself to remain hidden. Its estimated average distance of around 460 places it in a class larger than Neptune but smaller than Saturn, drifting through a region of space so remote and so dark that direct observation may remain out of reach for years or even decades to come. So if this world is functionally invisible to direct observation, how did anyone become confident enough in its existence to publish a paper about it in the first place? The answer has nothing to do with photographs, and everything to do with a set of numbers so improbable that most scientists find them difficult to dismiss. Picture 6 separate objects scattered across a vast, dark expanse hundreds of times farther from the Sun than Earth, each moving along its own independent path. Now imagine that all 6 of them, despite having no obvious reason to coordinate, happen to line up in almost exactly the same orbital orientation. Would that strike you as a coincidence? For Batygin and Brown, that alignment became the very first piece of indirect evidence for Planet 9. 6 icy bodies in the Kuiper Belt whose elongated, tilted orbits all clustered together in a way that, by their calculations, had only a 0.007% chance of happening randomly. In more intuitive terms, that is roughly a 1 in 14,000 shot. But why would 6 unrelated objects fall into that kind of pattern in the first place? The explanation the two researchers proposed involves a phenomenon known as orbital resonance locking. In simple terms, the gravity of a massive, distant object can gradually herd smaller bodies into synchronized, predictable patterns over long stretches of time, nudging their orbits into alignment the way a shepherd, almost imperceptibly, keeps a scattered flock moving in the same direction. According to the model published in the Astronomical Journal, this is precisely the mechanism Planet 9 would need to exert on the Kuiper Belt to produce the clustering that Batygin and Brown observed. That 0.007% figure became one of the most quoted numbers in the entire Planet 9 story, and for good reason. It is the kind of statistic that turns heads in any scientific field. Not impossible, but improbable enough that most researchers find it very hard to write off as noise. And the story did not end there. In 2021, the same research team returned with additional evidence, identifying more objects in the Kuiper belt with tilted, unusual orbits, and calculating a fresh probability of pure coincidence at around 0.025%. Two independent rounds of analysis years apart, both landing on numbers that hover in the same tiny fraction of a percent. Is that really just chance repeating itself twice? There is one more detail buried in this evidence that has proven especially hard to explain away. Some of the affected Kuiper belt objects don't just have unusual orbits. They orbit at a steep angle, nearly perpendicular to the flat plane in which most of the solar system's planets travel. No competing explanation, including alternate gravitational models or statistical flukes, has managed to account for that particular tilt as convincingly as the presence of a single massive distant gravitational anchor. Layer all of this together, the six-object clustering, the resonance locking mechanism, the perpendicular tilt, and the independent 2021 confirmation, and you get a body of indirect evidence that, while still not a photograph, is far more than a hunch. It is a mathematical fingerprint, repeated across multiple independent lines of analysis, all pointing toward the same conclusion. Of course, none of this means the case is closed, or that every scientist agrees on what that fingerprint actually belongs to. If you ever want to sanity check a headline about Planet 9 for yourself, there is a simple approach worth. First, check whether the underlying paper has been through formal peer review, or whether it is only an early preprint. Second, look at who the researchers are and whether they are affiliated with a credible institution. Third, ask whether the evidence being described is indirect, based on orbital modeling, or direct, meaning an actual image captured through a telescope. Fourth, read to the end of the paper, where responsible scientists almost always list the limitations and open questions in their own work. And finally, compare any bold claim against official statements from major space agencies before accepting it at face value. Because as convincing as this mathematical case is, it has not gone unchallenged. Not everyone in the scientific community is convinced that a single planet is the right explanation, and some of the alternative theories on the table are considerably stranger than a simple ninth planet. If Planet 9 exists, where did it actually come from? That question alone has splintered into several genuinely wild competing explanations, each with its own camp of serious researchers behind it. In 2023, a team at Cambridge led by Dr. Sarah Milholland proposed that Planet 9 might not have formed way out in the distant dark at all. Instead, it may have originally formed much closer to the Sun, only to be violently flung outward during the solar system's chaotic early years, most likely ejected by the immense gravity of Jupiter itself. Under this theory, the planet's extreme, elongated orbit isn't a mystery to be explained. It's simply the scar left behind from a very rough departure. A different research group offered a competing origin story entirely. In 2017, scientists from the Carnegie Institution and the University of Michigan, led by Juliet Becker, proposed that Planet 9 might not be a native of our solar system at all. Instead, it could be a rogue planet, a world that once drifted freely through interstellar space, untethered to any star, until it happened to pass close enough to our Sun to be gravitationally captured. Under this scenario, Planet 9 wouldn't be a long-lost sibling of Earth and Jupiter. It would be an interstellar visitor that simply never left. Then there is the theory that tends to make people do a double take. In 2019, physicists Jakob Schultz and James Unwin proposed, in a paper published in Physical Review Letters, that Planet 9 might not be a planet at all. It could instead be a primordial black hole, roughly planet-sized in mass, formed in the earliest moments of the universe. Unlike a stellar black hole formed from a collapsing star, a primordial black hole of this kind would have condensed directly out of the extreme density fluctuations of the infant cosmos, long before stars even existed. If true, this would mean the same gravitational fingerprints attributed to Planet 9 could actually belong to one of the strangest and most sought-after objects in modern physics. None of these ideas exist purely as speculation either. In 2020, a team at Durham University ran roughly 400 separate simulations to test how plausible the captured rogue planet scenario really was. Their results suggested the odds of such a capture happening were around 1%. A low number, certainly, but not one that can be dismissed outright. In a universe old enough and vast enough, a 1 in 100 event is not the same as an impossible one. But not every researcher is convinced there is anything unusual out there to begin with. A study from the University of Michigan, led by Kevin Napier, pushed back hard against the entire premise, arguing that the unusual orbits attributed to Planet Nine's influence might simply be the product of observational bias, an artifact of how different telescopes with different fields of view and different sensitivities happen to be more likely to spot objects in certain parts of the sky than others. In other words, maybe astronomers aren't seeing a pattern created by a hidden planet. Maybe they're seeing a pattern created by their own equipment. So which is it? An exiled planet, a captured interstellar wanderer, a primordial black hole, or simply a trick of observational bias? The honest answer is that nobody knows for certain, and the debate among serious researchers remains genuinely unresolved. But whichever explanation eventually wins out, one fact remains stubbornly unchanged. Nobody has actually seen this object yet in any form. And that brings us to one of the most ambitious searches in the history of astronomy. There is a precedent for all of this, and it dates back nearly 200 years. In 1846, a French mathematician named Urbain Le Verrier calculated the predicted position of an unseen planet using nothing but the mathematics of gravitational disturbance, without ever looking through a telescope himself. He sent his calculated coordinates to an observatory in Berlin, and astronomer Johann Galle pointed his telescope at that exact spot in the sky. Neptune was discovered within about 1 hour after decades of theoretical work. It remains one of the most stunning validations of pure mathematics in the history of science, and it is the direct ancestor of the entire Planet 9 hypothesis. That success planted a seed that would grow for decades. In 1905, astronomer Percival Lowell became convinced that something else, beyond Neptune, was tugging at the orbits of the outer planets in ways that couldn't be fully explained. He called this hypothetical world Planet X, and he was so confident in its existence that he built an entire observatory, the Lowell Observatory, largely dedicated to finding it. Lowell never lived to see the search completed. But in 1930, working at that same observatory, a young astronomer named Clyde Tombaugh discovered Pluto. For a moment, it seemed as though Lowell's prediction had been vindicated. Except Pluto turned out to be far too small and far too light to actually account for the orbital disturbances Lowell had originally calculated. The search for the real Planet X, in a sense, never actually ended. It just went quiet for decades. Fast forward to the modern search, and the tools have changed almost beyond recognition. Since 2016, Batygin and Brown have relied heavily on the Subaru telescope in Hawaii, an 8.2-meter instrument capable of surveying enormous swaths of sky with remarkable sensitivity. Night after night, year after year, the telescope has scanned methodically through the darkness, hunting for the faintest possible signature of movement against the background stars. As of 2024, the team estimates they have covered roughly 80% of the northern sky, along with a portion of the southern sky, and still nothing conclusive has turned up in that enormous searched region. And yet the story is far from over. On April 23, 2024, Batygin and Brown released a new preprint on Arxiv, not yet peer-reviewed but striking nonetheless, reporting 2 additional Kuiper Belt objects whose orbits appear to match the predicted influence of Planet 9. That brings the total number of unusual objects supporting the hypothesis to 8. NASA itself has publicly acknowledged an interest in this research, stating that the agency finds the work compelling, even while stopping short of committing to any dedicated search mission of its own. If you find yourself wanting to be part of this search rather than simply reading about it, there is actually a way to participate. Platforms like Zooniverse allow ordinary volunteers to sign up for free and help sift through real astronomical images collected from projects like Backyard Worlds, scanning for faint, moving objects that automated systems might miss. It typically takes no special equipment, just a bit of patience, a willingness to spend 15 minutes a day scanning frames, and the discipline to note down anything unusual you spot, alongside the time you saw it, so professional researchers can follow up. Thousands of amateur citizen scientists around the world are, in a very real sense, quietly hunting alongside Batygin and Brown right now. 2 centuries of searching, 2 successful discoveries using pure mathematics, and 1 planet that has evaded detection despite covering the majority of the visible sky. But before we look toward what comes next, it's worth clearing up a few misconceptions that have taken root in the public imagination, because much of what people assume about Planet 9 turns out to be wrong. Let's start with the most common misunderstanding. Many people picture Planet 9 as something like a second Jupiter, a colossal gas giant looming at the edge of the solar system. In reality, based on the original 2016 calculations, Planet 9 is estimated to be roughly 10 times the mass of Earth, which sounds enormous until you realize that Jupiter itself is more than 300 times more massive than Earth. Planet 9, if it exists, is closer in scale to an oversized ice giant, more like a bigger cousin of Neptune than anything resembling Jupiter's overwhelming bulk. Second misconception. A surprising number of people believe NASA has outright denied that Planet 9 exists. That is simply not accurate. NASA and its Jet Propulsion Laboratory have publicly described the hypothesis as a serious and worthwhile subject of ongoing research, one that could plausibly be confirmed with future observations. Skepticism and caution are not the same thing as denial, and conflating the two has led to a lot of confused headlines over the years. Here is where things get genuinely interesting, though. Some researchers believe Planet 9's influence might extend far beyond simply herding a handful of icy Kuiper Belt objects into unusual orbits. One striking calculation from Caltech astrophysicist Elizabeth Bailey in 2020 suggests that Planet 9's gravity could be responsible for a long-standing mystery. The fact that the plane of our solar system appears tilted by roughly 6 degrees relative to the Sun's own equator. Nobody had a fully satisfying explanation for that tilt, until a massive, distant object's steady gravitational pull was proposed as the cause. This has led some scientists to describe Planet 9's potential role in almost heroic terms as a kind of cosmic guardian. Under this model, the planet's gravity wouldn't just be reshaping the orbits of small icy bodies, it could also be intercepting long-period comets drifting in from the distant Oort cloud, deflecting some of them away from the inner solar system entirely, and in doing so quietly reducing the number of potential comet impacts Earth might otherwise face. Computer simulations from Batygин's team go a step further, suggesting this same gravitational influence could be responsible for flinging certain objects out of the solar system altogether. A mechanism researchers connect to the existence of mysterious interstellar visitors like Oumuamua, and to a broader pattern of missing objects that should exist in the Kuiper Belt, but simply don't. None of this began with Batygin and Brown either. Back in 2014, researchers Chad Trujillo and Scott Shepard published the discovery of a distant icy object called 2012 VP13, whose unusual orbit laid much of the groundwork that Batygin and Brown would later build upon. And this entire line of reasoning, using mathematical prediction to find planets before anyone actually sees them, has a long and successful track record. Uranus in 1781, Neptune in 1846, and Pluto in 1930 were all found, at least in part, through mathematical prediction preceding direct observation. Planet 9, in that sense, isn't a wild new idea. It's the latest chapter in a very old scientific tradition. So the picture that emerges isn't a giant obvious gas planet that everyone somehow missed. It's something smaller, quieter, and potentially far more consequential than most people assume. A possible architect of solar system tilt, a possible cosmic bodyguard against comet strikes, and quite possibly the missing explanation behind several long-standing puzzles all at once. The question now is simple. What tools might finally be powerful enough to actually catch it? The next few years may finally bring the breakthrough this search has been waiting decades for. Chief among the hopes is the Vera C. Rubin Observatory, under construction in Chile, home to an 8.4-meter telescope originally expected to be completed around 2025. Once fully operational, it is designed to repeatedly scan the entire southern sky using one of the most powerful astronomical cameras ever built, making it, in the eyes of many researchers, the single best tool humanity has ever pointed at this particular mystery. The James Webb Space Telescope, launched in 2021, adds another intriguing possibility to the mix. Thanks to its extraordinary sensitivity to infrared light, exactly the faint kind of glow a cold, distant world like Planet 9 might emit. Some scientists believe JWST could theoretically detect the planet if it happens to be sitting one of the regions the telescope observes. As of 2024, though, no such data has been published, and whether JWST's schedule will ever prioritize this particular search remains an open question. Meanwhile, the search has quietly become as much a story about computing power as it is about optics. In 2021, a research team at Harvard applied artificial intelligence techniques to comb through enormous volumes of orbital data, ultimately concluding that Planet 9 is very likely to exist. Even though the AI-assisted analysis still could not pin down anything close to an exact location. That's the strange paradox of this entire search. The math keeps getting more confident, while the exact coordinates remain frustratingly out of reach. Could a future AI model trained on data from Rubin and JWST combined finally be the tool that closes that gap? Other research groups have taken entirely different approaches to narrowing the search. In 2019, a Yale-led team headed by Milena Rice used data from the European Space Agency's Gaia satellite, originally designed to precisely map the positions and movements of over 1 billion stars, to calculate plausible orbital regions where Planet 9 might be hiding. The results narrowed the possibilities somewhat, but still left considerable uncertainty about the planet's exact position. A reminder that even our best data mapping tools have limits when the target is this faint and this far away. and the search keeps producing new leads even now. High up on Cerro Pachon, a mountain 662 meters in the Chilean Andes, engineers have spent over a decade and roughly $473 million building the Rubin Observatory's enormous 3-toon megapixel camera, a device capable of photographing the entire visible southern sky roughly once every 3 nights. It stands, quite literally, as one of the largest bets humanity has ever placed on finding a single hidden world. As one researcher connected to the project put it, sometimes the biggest discoveries in science simply require patience matched with an equally enormous amount of engineering ambition. Whether it's Rubin's cameras, Webb's infrared eyes, Gaia's stellar maps, or an AI model still being trained, the search for Planet 9 has become one of the most technologically layered hunts in the history of astronomy. And that raises a bigger question worth sitting with. If we do finally find it, what will that discovery actually mean for how we understand our own solar system? We started this journey with a strange kind of confidence, the idea that mathematics can see what our eyes and our telescopes cannot, at least not yet. From Batygin and Brown's original 2016 announcement to the ongoing hunt using instruments like Subaru, Rubin, and James Webb, the case for Planet 9 has only grown more intricate, more layered, and in many ways more compelling. And yet for all of that progress, real uncertainty remains. Is it a planet violently ejected during the solar system's chaotic youth? A rogue world captured from interstellar space? Or something far stranger like a primordial black hole hiding in plain sight? Even the skeptics, who argue the whole pattern might be observational bias, deserve to be taken seriously, because that is exactly how good science is supposed to work. What makes this search matter goes beyond a single hidden planet. It's a living continuation of the same method that found Neptune nearly 2 centuries ago, trusting the numbers before trusting your eyes, and being patient enough to wait for the universe to eventually confirm what the math has already been quietly suggesting all along. So here is where it's worth pausing. Somewhere out there, hundreds of times farther from the sun than we are, an answer is waiting, one that mathematics may have already found, long before any telescope catches up to it. What do you think is really out there?